When most people hear the term precipitation, they think about rain or snow falling from the sky. But we've learned that chemists think about precipitation a little differently. We've explored solubility guidelines and how they allow us to predict which cation and anion pairs will form solids. But just because you see a precipitation, it doesn't mean nothing is left in solution. Ions and solid are in equilibrium. Now we're going to learn about solubility equilibria. Let's dive into the deep end of the salty subject. This is Real Chem. Let's take a closer look at a classic precipitation reaction. Silver nitrate meets sodium chloride. We'll mix these together and zoom in to watch this chemistry play out. That's silver chloride, a solid precipitate forming right before our eyes. But here's the kicker. The solid isn't just sitting here. There's a dynamic dance happening where ions are constantly coming together to form the solid. It's all part of a dynamic chemical equilibrium process. This equilibrium is governed by a constant called the solubility product, or KSP. For silver chloride, the KSP is 1.8 times 10 to the minus 10. That tiny number tells us that only a small amount of silver and chloride ions exist in solution at equilibrium. Most of it stays as a solid. But what happens if we introduce a new player to the game? Let's add a strong Lewis base, 6 molar ammonia, to the mix. It looks like the silver chloride has disappeared. The ammonia reacts with the silver ions, forming a new soluble silver ammonia complex ion. The reaction to form this complex ion has an equilibrium constant known as a formation constant, Kf, of 1.7 times 10 to the 7th. This very large value tells us that the formation of the silver ammonia complex ion is highly favored. But this isn't the end of the story. It's just the beginning of the new equilibrium. I'm going to add a solution of sodium bromide. If you remember, bromine is right under chlorine in the halide group on the periodic table. As we move down the group, the KSP lowers. Silver bromide has a KSP of 5.0 times 10 to the minus 13. Watch what happens. We've swapped out silver chloride for silver bromide. Because bromide ions form a less soluble compound with silver, the equilibrium shifts and the silver precipitates out as silver bromide. To this precipitate, let's add another Lewis base, thiosulfate. That forms a highly stable complex ion with silver, with a very large formation constant of 2.9 times 10 to the 13. Let's see what happens now. Just like that, the silver bromide disappears. We have made a new complex that is soluble in water. The thiosulfate ions pull the silver into a new highly stable complex, completely shifting the equilibrium. What looks like a clear, colorless solution is actually a thunderstorm of ions, breaking apart, coming together, and dancing to the rules of dynamic equilibrium. Each addition, ammonia, bromide, thiosulfate, reshapes the balance, creating new compounds and shifting the chemistry in spectacular ways. Microscale reactions let us explore these chemical galaxies up close, minimizing waste and maximizing understanding. So grab your pipette and do some real chem as you explore the wonders of precipitation and complex formation reactions.